We're going to look at a tangent in the unit circle. I really enjoy this one. Really, you can link this in pretty easy if you get your head around it. So if we're looking at like the value of tan theta, for example, well, if you think about what tan is, if you've got your angle here, tan is really TOA, right? And we know that TOA is the opposite over the adjacent. What is opposite? Now remember when we looked at it before, opposite was sine, because it's sine over hypotenuse. So we could also say that, the opposite is also equal to sine theta, right? And we can also say that the adjacent is equal to cos theta. I love this one. So we could actually say that, well, tan theta is TOA, is equal to my opposite, which is sine, because it's opposite over hypotenuse. And remember, it's a unit circle, that's 1, so it's just sine. So it's my opposite, sine theta, over TOA, over my cos theta, adjacent. And that's where it comes from, because don't forget tan theta is opposite over adjacent. It's the opposite over the adjacent. And that's what we get. So for example, let's just say we have, and this will give you a bit of understanding of everything. Let's just look at this point over here, okay? Now don't forget, that's going to be -1, 0. Now, if I said sine pi, okay, so if we're talking about tan pi, and if I want to go, hey, what's the value of tan pi? Does anybody know what that is? Well, really, you've got to look at, well, what's the value of sine pi? Because we understand it's sine theta over cos theta. So sine pi is actually the value of y, and that is, well, nothing. Okay, so that is equal to nothing, okay? That's tan theta. And therefore, well, what's the value of cos pi? Well, the value of cos pi is the x-coordinate is -1. Well, 0 divided by -1 is still 0. Wow, we got so far there. But really, that's how you do. Later on, we're going to look at some exact values, and this will be really important about how you find the tan value. So you should know this, and it will link in a little bit more. Why tan theta is the same thing as, well, tan theta is sine theta over cos theta. So you just got to find those two ratios. Now you'll notice, or you might have been told that, whenever it hits this point or this point, it's undefined. Well, let's look at that. And this is beautiful because you're going to love this one. So that's going to be pi on 2, right? Like, because it's halfway around, or it could be 5 pi on 2 or whatever, as we keep on going around. So that's going to be really sine pi on 2 on cos pi on 2. Right? Now, we know that sine pi on 2, if you look at it, sine, don't forget, is the opposite. So that is going to have, that's going to be my y-coordinate. That has a value of 1. Now, cos is my x-coordinate. Well, my x-coordinate there, pi on 2, is 0. Oh, man. What happens when we divide by 0? Well, when we divide by 0, we can't define it, because you can't split one thing into no groups, or you can't split into sizes of nothing. It just infinitely keeps on going on. If you're not going to get rid of that one. So it's just a beautiful concept there. Hence, that equals undefined. Why this point and this point is undefined? Because if you think about the value of the denominator and the value when we're looking at tan, or even up here, we'll go up here. The value of this, whenever it lands on here or here, is going to equal 0. And 1 divided, or -1 divided by 0 is undefined. And that's why you're going to get an undefined value there. So let's go with, you need to find out a value of, say, tan, let's go with a -pi on 2. What is that? Well, -pi on 2, we start at 0, we go negative back pi on 2. Don't forget, it's sine over cos. Well, sine here is my y-coordinate. It's going to be -1 over 0. So that's going to be undefined. Now, if I had, say, tan negative pi, that'd be exactly the same thing as tan pi, because tan pi is here, but negative pi, we're going negative pi. Now, that's my sine coordinate, my y-coordinate, which is sine, which is 0, divided by -1 is 0. Okay, and that's really how we work that one out. Pretty easy. Hopefully, if you have any questions, let us know. But one last thing I forgot to talk about, which I really, really like, if you think about why we call things a tangent line and we measure them, or the angle, if you've got it actually on a Cartesian plane, we're talking about like a tangent line. Why we call this a tangent line, to a slope or anything like that, is because the angle it makes, if you make an angle in here, right, and you make this an angle, we call it the tangent line, because really it is the opposite over the adjacent, which gives you the gradient. I love that little bit there. We'll touch on that one a bit later too.